for this particular project that shows the mapping of the risk priority number ranges to the extent of testing. So basically any risk item that had a risk priority number between 1 and 12 was going to get extensively tested. 13 to 16 gets broad testing, 17 to 20 gets cursory testing, and 21 to 25 gets opportunistic testing. There's another extensive testing that's commonly used, which is report bugs only, which is not on here, which basically would be that if you found you would not do any testing against that risk item, but if you found a bug related to it, you would report it. Now you can see over here in the comments an explanation of the different extensive testing other than the report bugs only. But what I want to do is just try to illustrate these actually with an example that might complement the description that you see on the slide here. Let's suppose that you are testing a word processing application like Microsoft Word, and you've identified a risk in the area of functionality, fails to open supported file. Now, Word can open a lot of different types of files, and there are a lot of object types that can occur in a file. It's not just text, but it can be pictures and tables and headers and footers and different fonts and so on and so forth. So there's a lot of object types and a lot of file types. Now, you say you want to do extensive testing for that risk item, then you'd be saying that you want to make sure that you test every supported file type, and within every supported file type, every object type supported for that file type. So in other words, combinational types of testing. So that tends to be an expensive proposition, but if you say it's high risk, then that's what you need to do. Now, broad testing, you would say, no, I'm going to run every supported file type, and I'm going to test every supported file type, and I'm going to test every supported object type, but not combinations. I'm just going to make sure that every supported object type occurs at least once in some supported file type. Cursory, you'd say, well, I'm not even going to do that. I'm just going to select the most important file types, the most important object types, and I'm going to test those. And then opportunity, you would say, you know what, I'm not going to create any test specifically to test this, but I'm going to look for opportunities to exercise some file open functionality as part of testing something else. It's going to be a small and incremental investment. And then report bugs only, which I'm not showing here, but if you had that defined, then that would mean that you would not do any testing at all for this file open capability. But if you did see a file open bug in the course of testing something else, you would report it. Okay, so you can see this is the effort allocation table that they've got here, and I'll just point out the risk priority numbers associated with extensive testing. This is a pretty broad range, and you might say, wow, well that's really, they're going to do a lot of testing, and that's true, but this is a data center utility that really pretty much has to work in order for a data center to stay up. There's some pretty significant problems that are associated with this utility not working. So it's this kind of effort allocation is appropriate to the overall business risk associated with that application. Now, we get a finalized risk item, risk priority number, and effort and test case, traceability, and so forth. So the test manager then prioritizes the test cases based on the risk priority number, as I mentioned. And Jim, the test manager, told me that created some fairly significant changes from the older purely requirements-based approach. Before, what had happened a lot was that the tests were assigned to testers based on their experience, like who's the most qualified to run this test. Well, what ended up happening was you had a handful of people who were like the key players, had the most experience, and of course they ended up getting most of the tests assigned to them. Unfortunately, and not just most of the tests, but almost all the important tests. So what that ended up doing was delaying running of important tests, and thus the discovery of important bugs, so really late in the project. So what the insight that Jim got from this risk-based testing was, well, don't do that. You want to sequence the test based on risk, and look for some ways to get more creative about who runs what when. and that then changed the way that the tests were run, and the higher priority tests were run much earlier, lower priority ones later, and that with a consequent effect on bug finding. They also drove risk-based testing into their bug management process, so they started to augment their severity rankings with the risk prioritization of the test that had identified the bug, which is a creative thing to do. And then, when there are high-risk problems, they focus their bug fix efforts on that. Okay, so at the end of the project, we did a retrospective discussion, and what are the benefits and what are the key lessons learned from this pilot project. And in terms of benefits, they felt that they got an intelligent effort allocation within their constraints, that they did achieve the priority order bug discovery, and then optimized the bug fix time available for each bug based on its importance. They did experience some schedule compression, or actually it was resource compression. They had a resource get pulled off the test team, which before would have been a real problem, but they had some flexible handling options for that, and that allowed them to triage their tests and be effective and flexible in dealing with that resource constraint. And overall optimization of quality within the constraints due to the focused testing and an ability to talk about quality and quality risk with the key stakeholders, make an informed release decision. Now, some key points, some key lessons learned, things they wanted to do differently the next time. They wanted to include an even broader spectrum of business stakeholders. They felt that getting the impacts rated right was something that they needed even more focus on, and so that was something they wanted to do. In fact, they were even thinking of something that was fairly radical, which was inviting some of their beta test customers, who were real reliable customers, to participate in the process. So, obviously that entails a certain maturity level in the people involved, the customers involved. They can't look at it as an opportunity to beat people up, but it could very well work for them. They also wanted to start the risk analysis earlier in the life cycle. They wanted to start it in parallel with the requirement specification phase, which on a sequential life cycle model is definitely what you want to do. You maximize the benefits if you do that, particularly some of the side benefits of identifying problems in the requirements, but also just having the tests written in risk order ensures that the greatest amount of attention is given to the most important tests. So the overall conclusion at CA was that risk-based testing would allow them to deliver increasingly sophisticated and complex products, which we're all called upon to do. Products get more sophisticated and more complicated over time generally. But we all also called upon to deal with tightening constraints, particularly now, given the financial situation, and that risk-based testing helped them deal with the constraints, and allowed them to really prioritize testing and quality and balance that against the other priorities. So they're sold on it. As I said, we've done a number of risk-based testing pilots for CA at other locations around the world, and they're a big promoter of it, and I think a big success story of it just in general, and it's been very successfully deployed there, though of course we have successfully deployed it with a number of other clients as well. So this is not just a technique that only people in the enterprise software development business can do. We have clients that are banks and video game